Hello my dear students of class 12 science. Hope all of you are well. Please stay at home and stay safe. Today I am going to start the chapter solid state. First of all, you have to understand what is solid. So solid is a state of matter where the constituent particles are closely packed and are unable to move, and it possesses rigidity and hence definite shape and volume. Now solids are generally classified into two types. One is amorphous solid, another is crystalline solid. Now in crystalline solid substances, where the constituent particles are arranged in an orderly fashion, but in amorphous solid the constituent particles are not arranged in proper way over a long range. Now all of you know the examples of crystalline solid. We can think about sodium chloride crystal, we can think about the crystal of benzoic acid, crystal of diamond or quartz, etc. But the examples of amorphous solids are like rubber, plastic, glass, cornflour, etc. Now our main focus will be on the crystalline solid. First we shall discuss what is crystal lattice and unit cell. Now what is crystal lattice? A crystal lattice is a pattern of points that describes the arrangement of the constituent units in a crystal. Now what is unit cell? Unit cell is the smallest repeating unit in a crystal lattice, which when repeated again and again over in different directions results in the formation of crystal. Now we shall discuss the parameters required to explain one unit cell. So this one is one unit cell. Suppose this is A, B, C, D, E, F, G and H. Now this one is x-axis, this one is 0, O, x-axis, y-axis and this one is z-axis. Now if we think about the ABGA plane, that plane cuts the y-axis B, and if you think about the ADEF, this plane cuts the x-axis at a distance from the center A, and this plane this plane that CDAB cuts the z-axis at a distance from the center C. So these ABC are called axial lengths or axial distance, and the angle between the plane, suppose the angle between y and z axis is alpha and z and x axis is beta and x and y axis is gamma. So these alpha, beta, gamma are called axial angles. So these, based on this axial length and axial angles, there may be 7 type of crystal. That we will discuss later. Now we will discuss the type of the unit cell. Mainly 2 type of unit cells are there. One is primitive unit cell, another is centered unit cell. In case of primitive unit cell, the constituent atoms are arranged in a cube at the corner. These atoms, they are resides at the corner. So at 8 corners there are 8 atoms. or the constituent particles may be ions or molecules, but we are considering them as spheres. So this is also called simple unit cell or primitive unit cell. Now centered unit cell. In case of centered unit cell, there will be atoms in the corner as well as in any other parts of this cube. That means it may be in the center, it may be in the face like this. Now this centered unit cell may be classified into three types. One is body centered unit cell, another is face centered unit cell, another is end centered unit cell. In body centered unit cell, the atoms are arranged at the corners. So in this unit cell, in 8 corners there are 8 atoms, and in the middle there is one atom. That means at the body center there is one atom. So this type of arrangement is called arrangement of constituent particles or atoms is called body centered unit cell. In case of face centered unit cell, the atoms are arranged or constituent particles are arranged at the corner as well as the center of each face. Here 6 faces are there, so total number 6 atoms are also the center of the each face. And this type of arrangement is called face centered unit cell. Now one more is there, that is called end centered unit cell. Here in each corner of the cube there will be one atom or constituent particle, and the opposite face contains one atoms. Now this is end centered unit cell. Now we will discuss the number of atoms present in unit cell. So how to calculate the number of atoms in each cubic unit cell? We have to understand that the constituent particles, how much it is inside the unit cell or inside the cubic unit cell. Suppose if we think about the simple or primitive unit cell, then if we think about one particles or one atoms at the corner, this corner is shared by 8 unit cell. So the 1/8 portion of this atom will be inside this unit cell, and other 7/8 portion will be in the other 7 unit cell. So in this case, the total number of atom will be 8 corner atoms into 1/8 atom per unit cell. So 8 into 1/8, 1. So in case of simple or primitive unit cell, there will be only one atom. Now we will discuss in case of body centered unit cell. In body centered unit cell also there are 8 atoms in 8 corners. So each atom will contribute 1/8 portion to this unit cell, and so 8 into 1/8, and another atom that resides in the body center position that will not share with any other unit cell. So it has full contribution. So total number of atoms will be 8 into 1/8 plus 1, that will be 2. So in body centered unit cell there will be 2 atoms. Now in case of face centered unit cell, if you think about face centered, here also in each corner there will be one atom. So these atoms will contribute 1/8 to this unit cell, and there will be 6 constituent particles or atoms at the center of each face. Now the atoms present in the center of the face will also contribute to the another unit cell. So these atoms shares 2 unit cells. So each unit cell will get half portion. So in this case total 6 atoms of faces are there. So 6 into half atoms per unit cell, that means 3 atoms, and in each corner that means 8 into 1/8, so 1 atom. So total number of atom will be 8 into 1/8 plus 6 atom at faces into half atoms per unit cell. So total number of atoms will be 1 plus 3 is equal to 4. So in face centered unit cell the total number of atoms will be 4. Now we will discuss in case of end centered. In end centered unit cell total number of atom will be 8 into 1 by 8 and 2 at the faces, that means 2 into 1 by half, so total number of atom will be 2. Now we can easily understand the calculation of number of atoms in a cubic unit cell. Now we will discuss the packing efficiency. Now what is packing efficiency? Packing efficiency is the ability of packing of different types of atoms. If we think about any kind of packing, then there will be some void spaces. So how to calculate packing efficiency? So packing efficiency will be the volume occupied by the atoms and divided by volume of unit cell into 100. So in a particular volume, how much atom is occupied, that is called its packing efficiency. Now if we think about simple cube, here we have to assume one thing, that these constituent particles are like sphere and they are touching each other. So in this case, if we consider this diagram, then these two spheres are touching each other. So here this length will be the, that means axial length will be the A, and A will be equal to 2R. So here A is equal to 2R. So here A is equal to 2R. Now we have already discussed here that in simple or primitive unit cell there is only one atom. So volume occupied by one atom will be 4 by 3 pi r cube, because here r is the radius of the sphere. So as there is one sphere, so 4 by 3 pi r cube, and what will be the volume of this unit cell? That will be the A cube, and we know that A is equal to 2R, so total volume is equal to 8R cube. So if we divided the volume of occupied by atoms by volume of unit cell into 100, here if we calculate, we will get the percentage, that will be 52.4%. So in case of simple cubic unit cell, the packing efficiency or packing fraction is 52.4%. Next we will go for body centered cubic system. In body centered cubic system, I have shown this diagram, that in this center constituent particles, body center particles, touched with the other two corner particles, opposite corner particles. So here diagram is given. So in this diagram we can easily understand that if the radius of the sphere is r, so then this diagonal AD is equal to will be 4r. Okay. Now here some calculation is required. So if we think about this diagonal AC and AB and BC, if we apply the theory of Pythagoras, then we can write AB square plus BC square is equal to AC square. So AC is equal to root over AB square plus BC square. So we know that it is a cubic system, body centered cubic system. So here the axial length or this length AB and BC is equal to A, AB is equal to A and BC is equal to also A. So AC is equal to root over 2A, and if we calculate the AD, so AD is equal to, this one is A and this AC is root 2A and CD is A, so AD will be equal to root over AC square plus CD square, that will be equal to root 3A. Now we have to calculate the packing efficiency. Now from here we can understand that AD is equal to 4R, so root 3 is equal to 4R, so A is equal to 4R by root 3. Now packing efficiency, in this case, how many atoms are there in body centered cubic system or body centered unit cell? That will be 2. So the volume of this two atom will be 2 into 4 by 3 pi r cube, and divided by total volume. We know that A is equal to, in this case, 4r by root 3. So 4r by root 3 whole cube. So if we calculate it, this packing efficiency, 2 into 4 by 3 pi r cube divided by 4r by root 3 whole cube into 100%, then we will get the value 68%. So the packing efficiency in case of body centered cubic system is 68%. Now we will go for the face centered cubic unit cell. In case of face centered cubic unit cell, here we have to consider that these atom or constituent particles present in the face, center of the face, touches the two sphere at the opposite corner. So here if we draw the diagram will be like this. These three spheres touches each other. So here AC is equal to 4R. Now in this case, this AB and BC both are A. So if we apply the Pythagoras theorem, then we will get AB square plus BC square is equal to AC square. So AC is equal to root over AB square plus BC square. So AC is equal to root 2A. So from here we can tell that root 2A is equal to 4R. So A is equal to 4R by root 2. That will be equal to 2 by root 2R. So now if we calculate the packing efficiency, that the volume occupied by atoms in this face centered unit cell, there will be 4 atoms that we have already calculated. Now the volume of 4 atoms will be 4 into 4 by 3 pi r cube divided by the volume of this unit cell, that will be A cube, and we know that A is equal to 2 root 2R. So 2 root 2R whole cube into 100. So here packing efficiency, if we calculate, we will get 74.01%. So in case of face centered unit cell, here the packing is more dense or more closely packed compared to the other body centered or simple cubic system. So hope you can understand this calculation of number of atoms as well as packing efficiency. In my next video, I will discuss more about solids. So today up to this. Thank you very much. Stay safe and stay home.